Hello, Trig class. This video is going to start the lecture on section 7.6, which is about inverse trigonometric functions. Any inverse function is just defined to be the opposite of what the original function is. So, for example, if you had a function, well, let me put it this way. If your inverse function sent the number 7 to the number 4, then that means in the original function, it sent 4 to 7. The inverse just does the opposite of the original. So you can define your inverse in terms of doing the opposite of the original. And that's what inverse trig functions do. There's two different names that people have for the inverse sine function. One of them is just inverse sine, and the other is arc sine, but it means the same thing. So when people say inverse sine, they usually write it this way. It's really important to keep in mind that this does not mean the -1 power. This is not a reciprocal of sine. It just means inverse function of sine, just like this one does. That doesn't mean 1 over f. It means the inverse function of f. This doesn't mean 1 over sine. It means the inverse function of sine. So, but another way that people will denote it as a function is arc sine. And it means the same thing. All right, so I have this table in the book. There's 6 trig functions, so there's 6 inverse trig functions. They also have graphs of all the inverse trig functions, which are interesting, but they don't really help you solve the homework problems, and neither does like memorizing the domain of these functions. So what I'm going to do is just write out what is the most useful, and that is what their definition is, and that's what you need to use to solve the problems. So to start with, y is the inverse sine of x if and only if the sine of y equals x and your y can come from quadrant 1 or quadrant 4. And I'll talk more about those quadrants in a second. Y is the inverse cosine of x, inverse cosine of x, if and only if cosine of y equals x and your y's come from quadrant 1 or quadrant 2. Y is the inverse tangent of x if and only if the tangent of y is equal to x and your y's come from quadrant 1 or quadrant 4. Y is the inverse cosecant of x if and only if the cotangent or cosecant of y is equal to x and your y's come from quadrant 1 or quadrant 4. Y is the inverse secant of x if and only if the secant of y is equal to x and your y's come from quadrant 1 or quadrant 2. And lastly, y is the inverse cotangent of x if and only if the cotangent of y is equal to x and y comes from quadrant 1 or quadrant 4. Okay, and actually this is what we'll use to solve all the problems in this section and the stuff that came previously to this section. To explain a little about these quadrants that I'm talking about. Specifically, quadrant 4, the numbers have to lie between minus pi over 2 and 0. For quadrant 1, they have to lie between 0 and pi over 2. For quadrant 2, they have to lie between pi over 2 and pi. And quadrant 3 was not chosen as a quadrant to define the inverse sine function with, so we can just throw this one out. One thing you should notice that helps it remember where your angle comes from, whether it's quadrant 1, 2, or 4, depending upon which inverse trig function it is. They all come from one of two quadrants, but all of them include quadrant 1. So quadrant 1 works for every of the 6 inverse trig functions, so keep that in mind. And then when it comes to the other quadrants involved, it's either 2 or 4, and the ones that go with quadrant 4 are inverse sine, inverse tangent, inverse cosecant, and inverse cotangent. Okay? And the ones that go with quadrant 2 are inverse secant and inverse cosine. Each of these are chosen so that when you look at the 6 trig functions, you'll get a quadrant where it's positive in one quadrant and negative in the other. So that's another way to help keep track of what's going on. For example, cosine is positive in the first quadrant and negative in the second quadrant, and that's not an accident. Tangent. Tangent is positive in the first and negative in the fourth. Again, the pairing of quadrants are always so that one is plus and one is minus, and of course all 6 trig functions are positive in the first quadrant. Okay, so let's get to work on solving the kind of problems that are in this section, but they all pretty much just use these definitions. So first of all, we'll use our definitions to work our way through these calculations. starting with arctangent. Now arctangent is just another name for inverse tangent. They mean the exact same thing, and I'll write it the inverse tangent way. And then I'll figure out what the inverse tangent of -1 is, because that's the same thing as saying the tangent of y is -1. Go find what y is. So I'm going to assign this to be the value of y, and use the fact that y is the inverse tangent of -1 if and only if the tangent of y is -1 and it lies in quadrant 1 or quadrant 4. Okay. Well, one way you can think about -1 is it's the same as -1/1. And if you think about it that way, then you have a opposite side and an adjacent side, which tangent has. So that means that you are in the 4th quadrant, and you're going to go to the right 1, and you're going to go down -1, or down 1, which I'll mark as a -1. Okay, that means these side lengths are the same, and that makes this guy square root of 2, because if these are both 1, then that's a special 45, 45, 90 degree triangle. So this is the triangle in general for 45, 45, 90. So it's a 45-degree reference triangle, but you would go backward, you'd go clockwise to make this angle. So we would say that the y has to be a -45 degrees, because you're going clockwise, or a -π/4. So that means the inverse tangent of -1 is -π/4. Okay, so there's the first one. Let's do cosecant. Well, the way cosecant works is this way. Y is the inverse cosecant if and only if the cosecant of y is the number that you're plugging in for the x, and your y's come from quadrant 1 or quadrant 4 again. Okay, so this is equal to y if and only if 2 is equal to cosecant of y, and your y is coming from quadrant 1 or quadrant 4 again. I can think of the number 2 as 2/1. That way I can have a hypotenuse and I can have a opposite side, because cosecant is hypotenuse divided by opposite. Okay, so that would mean I would go some amount to the right. I would go up 1, and my hypotenuse would be 2. But we recognize those lengths of a triangle. That's a special triangle. So that makes this guy 30 degrees, or π/6, and this side itself is square root of 3. That's a 30, 60, 90. Okay, so that means y is 30 degrees or π/6. So this one is π/6. and we will continue in that in the next video.